Here we have a stone being thrown vertically upward from a bridge with an initial velocity of 64 feet per second, and at height of the bridge we're starting out at 32 feet above the ground. And the height of the stone in feet, t seconds after we have it thrown, is given by this s of t function here. We're going to use derivatives to go from position to velocity to acceleration. As we do, we're going to keep in mind our units. The position is in feet, so the velocity will be in feet per second, and the acceleration will be in feet per second squared if we plug in. So first off, determining the feet after t second, the velocity is going to be the derivative, so negative 32t plus 64. When does the stone reach the highest point? If we want to find a max or a min, here we're looking for a max, the velocity at any maximum, we want to set v of t equal to 0 and solve. So we're going to set negative 32t plus 64 equal to 0 and solve it. So I can add 32t to the other side. I'd rather work with positive numbers than negative numbers. So instead of subtracting 64, I'll add 32, and then I'll divide by 32. So the time is going to be 64 divided by 32. It's going to take 2 seconds to reach that maximum height. So we've answered when it hits the highest point. It says with what is the height for the highest point though. So to find the heights for the highest point, we know it happens after 2 seconds, and we want to see the position that it is. So we're going to plug into the position function, this original function here, negative 16 times 2 squared plus 64 times 2 plus 32 into that original function. It's 96 feet in the air. When does the stone hit the ground? Well, if we want to think about when the stone hits the ground, we want to think when the height is 0. So anytime we want to figure out when we're touching the ground, we're going to set the position to be 0, which is trickier than setting the derivative for this one because the position has a t squared. So it's not a linear function where we can just isolate t like we did with the velocity above. It has a t squared, so we can try to factor it. But if we try to factor this one, if I pull out a negative 16 times t squared minus 4t plus 2, there's nothing that multiplies to be 2 besides 2 and 1. And so this would be negative 2 and negative 1, and those add up to be negative 3. So we can't factor this. We're going to go ahead and use the quadratic formula then. So the quadratic formula, the x value is normally negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to use that here. It's going to give us our t value though instead of x. So the time that it hits the ground is going to be negative, and we have our letters here, A, B, and C. So negative 64 plus or minus the square root of 64 squared minus 4 times negative 16 times 32. So when I plug in negative, that b squared minus 4ac, I'm getting 6,144. I'm going to calculate that discriminant right off to the side. And then 2 times a is negative 16. So our t value that we get, if we add or subtract, we're going to get negative 0.45-ish and about 4.5 for our two t values. So we can't have a negative amount of time. So the time is going to be approximately 4.5. It's 4.4449. So somewhere around 4.4 or 4.5. We have our stone hitting the ground. So I'm going to put units on that, that's seconds. So about 4.4 seconds later, after we've thrown it 2 seconds up, it is hitting its max. About 4.5 seconds later, it has gone back to the ground. So with what velocity does the stone hit the ground? Well, we're going to take that time and plug it into our velocity function. It doesn't tell us where to round to on this, so I'm just going to stop at 4.449. And I'm going to plug it into velocity. So negative 32 times 4.449 plus 64. Our velocity is negative 78.4, and that is velocity, so it's in feet per second. Does it make sense that it's a negative velocity when it hits the ground? It should be negative because it should be going down as it hits the ground. So I'd be concerned if I got a positive velocity as it hit the ground. So it's about negative 78.4 feet per second. And then it says, when is the speed increasing? To figure out when the speed is increasing, we need to look at the acceleration. So I'm going to take the derivative of velocity. So my velocity function above was negative 32t plus 64. So the derivative of negative 32t is negative 32. Derivative of 64 is 0. So I have my acceleration and my velocity, negative 32t plus 64. I want to see when their signs are the same. So I'm going to put a sign chart in here for both of them. So A of t is negative everywhere. It's always negative 32 no matter what. V of t is a little bit more interesting. We said that the velocity is 0 at 2 seconds. And so before 2, we just need to test a value into that velocity function. So we could plug in 0 or 1 here, something before 2, even 1.9 would be fine. But we're going to see that the velocity starts off as being positive, which makes sense. We're throwing the stone up in the air. So it starts off positive. It hits a 0 velocity. And then what do you think is going to happen with the velocity as it goes down? Well, we already actually plugged in 4.4 into the velocity. So we've tested a value after and we got a negative 78. So it's going to be negative even if you plug in 3, 4.4, any value to that side. So we want to see when the signs are opposite and when they're matching to see when they're speeding up and slowing down. So speeding up means matching. The signs match from 2 on to, well, is it really going to be infinity for this one? No, we know it. The stone hits the ground, so it's not going to be 2 to infinity. It's going to be 2 to that 4.449 seconds when it hits the ground. It's hit the ground after that. So it's not falling forever. If you threw a rock when you were 4 years old, it's not still falling now. This one stopped falling about 4.5 seconds in. It's slowing down before 2, so from 0 to 2. This only asks speeding up though. So it is speeding up from 2 seconds, not included, until it hits the ground, 4.449. It's going to hit with a negative velocity and acceleration. So you can argue either set of parentheses here. I would say you could include it because both velocity and acceleration are negative though. So from 2 to infinity normally, but we know this is a stone hitting the ground, so from 2 until the time it hits the ground.